Hello everybody, welcome back to our YouTube channel of Department of Physics, Veer Bahadur Singh, Purvanchal University, Jaunpur. So, in previous video, we have talked about analog computer and its system description, and we have solved a simple two variable equation using analog computer. And I have told you in that video that in upcoming video we will talk about a little bit complex two variable equation and three variable equation using summer amplifier. So in this video we are going to perform those equations and I will show you that how those equations will turn into our like with the help of summer amplifier how we will get our result. Okay, so let's proceed the steps. So before we proceed our steps on analog computer, let us take a look on our equation. So let's take x plus 3y equal to 7. This is my equation 1. And 2x plus y equal to 4. This is my equation 2. So firstly we will solve this equation mathematically. So how can we do that? If we will multiply this with 2, then we will solve it easily. So what we will get? We will get 2x plus 6y equal to 14. Okay, so we got here our equation 3. Now if I will solve this like, yeah, then what I will get? I will get minus 5y equal to minus 10, then y equal to 2. And if I will put the value of y in my equation 1, then what I will get? I will get the value of x equal to 1. Okay, so I will get x equal to 1. So these are my values of x and y, and we will get this value when we will perform our experiment. Okay, so as I already told you that I can't put these two equation directly in my analog computer. I have to make some changes, so let's do that here. So what should I do? I should yeah, x I have to like do this minus 7 equal to minus 3y. And what changes I can do here? I can like make this yeah, y minus 4 equal to y minus 4 equal to minus 2x. Yeah, so now we got our equation that we can like put in our analog computer, and yeah, this equation will give us result. So before I like to perform this there, what I have to do, let me show you how it will work there. Okay, so let's take two input. I am giving it x volt here and minus 7 volt here. Then what I will get? I will get according to this I will get minus 3y, but I already told you that when it goes through this process it turns its value into like plus. So what I will get? I will get plus 3y. Okay, so for second equation, what I want, I want y minus 4 volt. Okay, so I have 3y, and I have to make this 3y to y. And how can I make this y? What I have to do? Okay, see this process here. I have to make 3y equal to y. So what I have to do? Y equal to y by 3. Okay, so and yeah, we have like 10 volts, so we have to convert 10 volt by 3 equal to 3.33. So if I will like give it 3.33 volt, then my y will turn into y, then my 3y will turn into y. So how will I? Okay, I will show this value how I am getting there. Okay, so if I am applying minus 4 volt here, minus 4 volt here, and we have 3y, we have to make this 3y, then what I will do? I will like add this with coefficient potentiometer. Then I will make my 10 volt to 3.33 volt, and I will like add this 3.33 volt to here, because this is my y value. Then what I will get? I will get y and minus 4. Then yeah, it will goes through the summer amplifier. What I have here? I have minus 4 plus y. Okay, now it will goes through summer amplifier. Then what I will get? I will, according to this I am getting minus 2x, but what I will get? I will get plus 2x. Okay, so now I have to make this 2x x, because here I have x, so I can't directly connect it. So I can make this x. Similarly, that like how I performed this here, I will have to do the same step. So like I have to use my coefficient potentiometer. What I have to do, I have to like make my 10 volts to what I have to do, I have to like, if I will do 10 by 2, then what I will get? 5. So if I will apply 5 volt here, 5 volt here, then what I will get? I will get x. So yeah, I will get my x value. With here I have got my x value, so I can like continue this circuit further, or I can simply connect it here. Okay, so this is all about we are going to do there. Okay, so now let's see this on our system. So now we are ready to perform our experiment, because now we have got our equation. Okay, so from here you can see that our equation is x minus 7 equal to minus 3y, and y minus 4 equal to minus 2x. So yeah, we are going to use these two equations. Okay, so now you will see that how I will use this. So let's perform our experiment. So what I have to do first, I have to like, I don't know the value of x, so I have to find the value of x. So let's start with this. Okay, so I have already mentioned you in my previous video that this one summer amplifier is not working properly, so I will not use this. Okay, so yeah, let's leave this here. So from equation you know that I want minus 7 volt. Okay, so let's see this from here. Here is my minus reference, like minus 10 volt is here, plus 10 volt is here. So I want minus 7 volts. So what I will do, I will add this one here, and yeah, this one. Actually, I will show you my every reading on my multimeter, so that actually multimeter measure the voltage with more precision. So yeah, we should use multimeter. Okay, so let's see what we are getting here. Okay, so I think you are able to see that I am getting here minus 7.06. So yeah, it's accurate value, almost accurate value. So what I have to do, I have to like take my patch cord and add it here, because here is minus 7.06 volt, and I have to like apply it here. Okay, so actually yeah, now what I have to do next, so I have got here minus 3y, and it will turn into plus 3y, but now neither I want 3y, minus 3y or plus 3y. I want y, so I have to make this one y. So what I can do, if actually I have already told you the process here, like how I will turn this into y. So yeah, I will like perform it here. So what I have to do, if I will apply 3.33 volt, if I will apply 3.33 volt, then what I will get? I will get y. So what I have to do, here is my positive reference. Yeah, it's 10 volt, and here it goes, and yeah, so I have to make this 3.3. So if you will see this here, that, so yeah, it's almost 3.3. You can see that 3.297. So yeah, it's almost 3. Actually, I think you were surprised that how I am getting the accurate voltage. So I already like yeah, performed this. So this voltage is already set. So I am getting it one by one. So now what I have to do? I have to do. Yeah, I am taking another patch cord, and yeah, now what it become, it is my minus y, actually sorry, plus y, it is my plus y. So what I have to do, I have to add it to another summer amplifier input, and yeah, I am adding this here. So yeah, from here what happened, my 3y turn it to y. Okay, so I have got here y. So from the equation 2, yeah, like from this equation you can see that y minus 4 equal to 2x minus 2x. So what I want minus 4 volts. So now I am going to give it minus 4 volt. Okay, so now we will give it minus 4 volt. So what I have to do, I have to add my one patch cord to minus reference, this one here, and now let's measure the value with multimeter. Okay, okay, so I okay, so I hope you are able to see this, that it is almost minus 4.074. So yeah, it's now what I have to do, I have to take my minus value and I have to add it here. So yeah, it's like minus 4 plus y. So what I will get minus 2x, but when it goes to this, it will turn it into plus 2x. So what I am getting here, I am getting here plus 2x, but what I want x. So now I have to repeat the same process which I did here to make 3y to y. So what I have to do, actually I have already told you here what I have to do. Okay, I hope you are able to see it. I have to do this. So what I have to do, I have to apply 5 volt. If I will apply 5 volt, then it will become x. So let's see that. Okay, so I have to apply 5 volt. Here is my positive reference. Here is my this coefficient potentiometer, and yeah, let's measure the value what I am getting. Okay, let's see. Okay. Okay, I hope you are able to see that. I think I should like do some changes in this. Actually, it's not 5, it's almost 5, but oh, it's not 5. Okay, so let me make some changes into this. So yeah, it's my fourth coefficient potentiometer, so I will use fourth coefficient potentiometer, and yeah, let me increase the value of this. Okay, so yeah, okay, so leave it here. So yeah, it's almost 5. Now what I have to do, I have to take my this patch cord. So what it become x. So now what I can do, actually first let me put that here. Okay, so it's my 2x, and yeah, 2x become here x, so it's my x. So I can like add the circuit further, but I am not going to do that. What I can do, let me remove this from here. Actually what I want to add x to x. So here I got x, so what I can do, I can add it here. Okay, so I can add it here. So what I will do, I will add it here. So now my circuit is completed. So yeah, this is all I wanted. So now let's check the result what we have got. So according to this, what we should get, so we should get y equal to 2 and x equal to 1. Let's see we are getting this or not. Okay, so from where I can measure x voltage, yeah. So actually this one patch cord is not good enough to perform my experiment. So let me add another one. Okay, so yeah, now it's perfect. Okay, so let's measure the value of x. So yeah, here is minus my x. So let me like lose it a little bit. Yeah, now we will see that. Okay, okay, it's okay. So we are getting 1.049. Yeah, it's good. Yeah, so we are getting 1.049, and what we should get 1.000. Okay, okay, okay. So it's my x value. So yeah, I told you that here is 2x. So what should I get? I think that yeah, it's 1.029. So yeah, 2.1. Let's see that here what we are getting. Yeah, 2.154. So yeah, it's 2x. So here is the 1. So it become like 2x to 2. So 2. Okay, now where is my y? Let's see where is my y. Okay, so yeah, here is 3y make it y, and here is my y. So let's measure this. So what we are getting from our mathematical value, we are getting 2y. Let's see. Okay, so yeah, here is 2.0. Oh, wait. Okay, got it. Okay, so it's almost 2. We are getting 1.9992. Okay, we are getting 1.991 and 2. Yeah, 9192. So yeah, it's almost 2. So what should we get here? Like almost 6 because it's 3y. Let's check it. Yeah, 6.09. So yeah, we are almost getting the same value. Yeah, it's almost same. So from this we can say that the experimental value and the mathematical value is almost same. So okay, so yeah, let me write this. So it, okay, I will show you. Wait for a minute. What I am getting, y equal to 1.991 and x equal to 1.049. Okay, so yeah, from now you can see that here m represent the mathematical value and e represent the experimental value, and what I am getting, you can see that so I should get y equal to 2, but what I am getting 1.992 and x equal to 1, and what I am getting 1.049. So yeah, it's almost same. So here we completed our experiment of a little bit complex variable equation. Like yeah, we wanted to solve the equation of two variable but a little bit complex variable. So we did it successfully. So now we will perform three variable equation. So let's proceed to three variable equation. So now we are going to solve three variable equation on our analog computer. So before we start to proceed the experiment on our analog computer, let's take a look on our equations. So yeah, it's for three variable equation. Okay, it's for three variable equation. So let's take our equation. Okay, so minus x plus y minus z equal to 0, and here x plus z equal to 3, and yeah, y minus x equal to 2. So it's my equation 1, it's my equation 2, it's my equation 3. So if we solve this mathematically, so what I can do, I can like yeah put the value of minus x from here. So what I will do, okay, so minus x equal to 2 minus y. If I put the value a here, what I will get minus sorry 2 minus y plus y minus z equal to 0. So yeah, it's like minus z equal to minus 2, so z equal to 2. If I will put the value of z here, then what I will get, I will get the value of x, and x equal to, okay, 1. Yeah, x equal to 1. And if I will put the value of x here, what I will get, y equal to 3. Okay, so I get the value of x is 1, y is 3, and z it is 2. Okay, so yeah, this is the value that we are going to get there. So before doing the experiment on our analog computer, let's make some changes here. So what changes I can make? Let's see that what changes I can do that here, so that my equation become easy to put on my analog computer. So yeah, what I can do from here, I can do minus y equal to minus z minus x. Okay, and from here what I can do, I could yeah, I can do 3 minus x. So yeah, it's 2, and from here I can do x equal to y minus 2. Yeah, minus 2, it's 3. So now what I have to do, I have got my equation in this form, that yeah, I can easily put this equation on my analog computer. So let's take a look on how I will do that on my analog computer. So let's start with this one. Yeah, this seems easy. So we are taking x equal to y minus 2. What we are going to do, let's take a look here. Here I am giving it minus 2 volt, here is my y. So yeah, so when it will pass through this, it will turn it into plus y. Okay, so yeah, I can easily add my plus y to here plus y. So yeah, this is the thing that I am going to perform on my analog computer. Okay, so let's see this on our analog computer. And yeah, after performing this, what I should get this value. Okay, so let's see this on our analog computer. So now we are going to perform three variable equation. So yeah, from here you can see that I have solved this mathematically, and now I am going to perform this on my analog computer. So I will start with this equation, x equal to y minus 2. So what I have to do, I have to apply y volt and minus 2 volt. Okay, so let's see this on our analog computer. So I don't know the value of y. So firstly, let's yeah connect y. Okay, leave it here. Now what I have to do, I have to add minus 2 volts. So yeah, you can see that from here. And yeah, let's on our multimeter and let's measure the voltage. So yeah, it's minus 2.005. Okay. Yeah, I have already mentioned you that I already performed this. So this value is already set so that I am getting it so accurate. Okay. So I added this here. This is my y. So if I will perform this, what I will get from this, you can see that I will get x. Okay, x. So here is my x. Okay, wait. Okay, so here is my x, but when it will goes to my summer amplifier, it will become minus x. So now we will move in into equation 2. So from here we can see that 3 minus x equal to z. So I have got my minus x value and I will apply 3 volt. Then what I will get? I will get z. So yeah, let's see that here. So I have to apply 3 volt. 3 volt. So how can I apply 3 volt? Let's add this one here, this one here, and when you will check this on multimeter, you will find that it's yeah almost 3 volt, 3.027. Okay, so let's add this one here and here, and yeah, take one patch cord to add this one here. Okay, so what it become z, but when it goes to this it become minus z. So what I have here, I have minus z. So from the equation, okay, from the equation you can see that if I will get minus no sorry if I will get yeah minus z and minus x, then what I will have minus y. So let's see that how can I get it. So you know that here I got minus x. So if I apply this minus x here, and if I apply minus z here, then what I should get? I should get minus y. But when minus y goes through this, it will become plus y. So I can easily add plus y to here. Okay, so let's do that. What I have to do? Here is minus x. So let's take minus x here, and here is minus z. So let's take minus z here, and now let's complete our circuit. Okay, so yeah, here is our y, here is our z, and here is our x. So now let's measure the value. So from this, what should I get? What should I get? Yeah, x equal to 1, y equal to 3, and z equal to 2. So let's see we are getting this value or not. Okay, so let's measure this. So here I have y. Okay, so let's see this if I am getting or not. Okay, so I should get 3, and it's 3.039. So yeah, it's almost same. And here is my z, and my z is 2 point wait 2.008. Okay, and here is my wait here is my x, so it should be 1. Okay, so it is 1. So yeah, from this we can say that our experimental value and our mathematical value is is almost same. So here we successfully completed our experiment, So in this video we have covered how to find, like, how to solve a two variable equation and how to solve three variable equation. And in upcoming video we will discuss about how to solve, like, solution of linear differential equation of harmonic oscillator. Okay, so in upcoming video we will see that. Here we successfully completed our uh, like work with summer amplifier. I hope you understand this properly, how the things are going. And yeah, this was all about summer amplifier and its function and how we can use summer amplifier. So yeah, this was all about it. I hope you liked the video. And yeah, thank you for watching.